All right, we got a big factor review today. So let's just get started. There's, we talked a lot in class about what all we were going to do, but let's just have at it. So, x cubed minus 4x squared minus 5x. Let's factor out the greatest common factor because we always do that first. Now I've got a trinomial. Trinomials, if they're going to factor, will break down into the product of two binomials. And we're hunting for what multiplies to be negative 5, adds up to be negative 4. That's a negative 5 and a positive 1. This one, greatest common factor is what? 3y cubed. That leaves a y squared minus 16. Now, since I only put this is the title, I should probably stop for a second, go do these, and I'll come back. So, difference of two squares. Remember, if you've got anything squared minus something else squared, it breaks down to a plus a b. Oops. Multiplied by an a minus a b. So, x squared minus 121. All those are perfect squares. One of the binomials is a sum. One's a difference. What do you square to get x squared? What do you square to get 11? Over here, same thing. Everything here is a perfect square. It's a difference. So what do you square to get 4x squared? That's a 2x. What do you square to get 9? That's a 3. And then we've got it. And then I'm going to come back up here because that's a difference of two squares right there on the end of that. And I'm going to keep going. Oops. Factor down that y squared minus 16. That's a y plus 4 and a y minus 4. So you don't quit factoring until it's completely factored. Trinomials with a lead coefficient that's not 1. Oops. Wow. Pen's got a delay in it. That's weird. We're going to do trial and error. Look at the front first. I need those front two terms to make a 2x squared. There's lots of ways of getting that negative 12 on the back end. So, it's just play with the numbers until it works. 1 and 12. That'd be a 24 and a 1. Yeah, I can't make a 5. What if I did 12 and 1? 2x and 12x. Nope, can't make a 5. Let's move on to 6 and 2. 4x, 6x. Nope. 2 and 6. 12x, 2x. Nope. Let's go to 3 and 4. 8x, 3. Oh, here we go. Doesn't mean it has to work, but there's a good chance it could. So if I were to take and multiply this out, not worry about any signs, I'd have a 2x squared, an 8x, a 3x, and a 12. Now, based on what the signs are, that'll figure out whether it's positive or negative as I go along. I need this to be a negative 12, which means these two have to be different signs, the 3 and the 4. But when it gets put together in the middle, I want to add up to negative 5x. So if I make the 8x negative and the 3x positive, that'll give me my negative 5x. So I want the 8x to be negative and the 3x to be positive. And then I've got it factored. Okay. Perfect square trinomials. You're just looking at it and you recognize it. Front and back are perfect squares. What do you square to get x? What do you square to get 25? 5 and 5 do make 10. Got it. Of course, you could say what multiplies to be 25 and adds up to be 10. You'd say it's positive 5 and positive 5. But I say you're better off if you recognize those perfect square trinomials. Okay, factor by group it. Again, this is a review. If we take out the r, take out the positive s, these two both have an a plus b in common, and it leaves an r plus s. Got it? This one, we're going to go over the exact same factor problem we did a second ago. Hang on. We're just going to do it with the method instead of the trial and error. So if you've been struggling figuring out how to factor these, here's a surefire method. If you have a trinomial of any type, multiply the front times the back. That'll give me negative 24x squared. And then look at the middle term. If you can find two terms that multiply to be negative 24x squared and that add up to be negative 5x, then we're good. And a negative 8x and a 3x will do just that. They multiply to be negative 24x squared. They add it to be negative 5x. So I'm going to take this middle term out and replace that with those two terms, because then I can factor by grouping. Take a positive 3. Now each of those has an x minus 4 in them, and it leaves me with a 2x plus 3. Okay. So if you, again, would I prefer you to do trial and error? Of course, because it's just so much faster and I think better for your brain in the long run. But if you need an alternative, learn that and you'll be fine. Okay. And then pretty much we didn't get as far into today's lesson as I'd hoped we would. So we're going to do some long division to figure out a new factored method. So when we've been doing long division and synthetic division, you fill in the spaces, fill in the placeholders. Well, this is the first time you've ever done with two variables in it. So think about what happens in Pascal's triangle. Like, it starts out at the highest power and that works its way down, and the other variable starts out with none of them. It works its way up. So if you start out with an f cubed, there could be an f squared s term that shows up, but you don't have any. So I'm going to put 0 there. Then I'm going to lose another f, but gain an s. And then s cubed. Okay, so there's what I'm dividing into. That's my dividend. Now I'm going to do long division like normal. What I'm going to multiply f by to get f cubed, that's f squared. F squared times s is f squared times s. But I'm subtracting. Pull the next one down. What I'm going to apply f by to get negative fs squared, that's a negative fs. Again, I'm subtracting. When you multiply f by to get fs squared, that's a positive f squared. And then when I subtract that out, I have a 0 remainder. So what I just figured out is that an f cubed plus an s cubed, when I divide it by the quantity f plus s, I get f squared minus fs plus s squared. But what that means is that if I were to multiply f plus s times f squared minus fs plus s squared, I would get f cubed plus s cubed. Remember, same reason. This 10 divided by 2 is 5 because 2 times 5 is 10. But instead of just multiplying things out and getting an answer, we're learning how to factor. So we're starting over here and factoring it down into that right there. All right, now I did put in class, I figured that we would practice up our long division, but I stopped right here and tried to explain to everybody what exactly this meant, and it took forever. So I ended up not doing the long division for this one. But I can tell you that this equals, if you did the long division, it equals that. Which means that f cubed minus s cubed is f minus s times an f squared plus an fs plus an s squared. And then I already knew this one. And these are the way you factor the sum or the difference of two cubes. And here's the rule put into one step, where if you see something, that's not, there you go. It's not that I necessarily would write it this way, but I do want you to know what it means if you see somebody else write it this way. It's a way of saying both those things at once, where if you see plus or minuses or minus pluses, like that's a totally okay thing to have. Whatever's on top goes together. So f cubed plus s cubed equals f plus s, all that times the quantity f squared minus fs plus s squared, because that was what was all across the top. And then across the bottom is f cubed minus s cubed equals the quantity f minus s times the quantity f squared plus fs plus s squared. Now, you're sitting here at home going, why in the world is she just mumbling off about f's and s's? Okay, first, well, I just said what it is. The f stands for first and the s stands for second. So let me kind of show you what's going on. F cubed minus s cubed, because there's something sitting there getting cubed to make an x cubed. It equals the first minus the second. So the first is whatever you cubed to get f cubed. What did you cube to get x cubed? X. They've got a minus, you've got a minus. What did you cube to get 125? And that's a 5. Now for the rest of it, quit looking at the problem. The rest of the factor you take the first one and square it. You put a plus sign. It always changes signs. You do the first times the second. X times 5 is 5x. And then you add in where you square that 5. And that is how to factor it. So what you're asking yourself, is everything a perfect cube? Yes. Then you go, what do you cube to get 8x cubed? And that's a 2x. They got a minus, you got a minus. What do you cube to get 1? That's a 1. Okay, so then you square this first one. 2x, when you square it, is a 4x squared. You change the sign from the front. You multiply the two together. 2x times 1 is 2x. And then you add in the back one squared. Okay. What do you cube to get x cubed? X. They got a plus, you got a plus. What do you cube to get 27? 3. And you square the back one, change the sign, times the two together, add in the back one squared. I said square the back one, I think a second ago. I meant square the front one. And then right here, oh, if you're in second period, just quit listening. Well, actually, I probably should do that. I'll stop at where we got in third period because they got a little farther. And then maybe that'll be all right, because I'm going to stop right there because that's as far as we got in third period. So if you got this far, you're actually about where we got in second period. But a combination of methods, you just take, okay, greatest common factor is a 2. Oop, that does not look like 2. And then an x squared. And that's going to leave me with an 8x cubed minus 125. But 8's 2 cubed. X cubed is x cubed. 125 is 5 cubed. So this is a difference of 2 cubes. What did I cube to get 8x cubed? 2x. They got a minus, I got a minus. What did I cube to get 125? 5. And then I'm going to square that 2x. Change the sign that's in between, multiply the two together. 2x times 5 is 10x, and add in the back one squared. Over here, let's see, that's a difference of 2 squares. I square a 9x squared to get 81x to the 4th, and I square a 4 to get 16, but I'm not done, because the back one is another difference of 2 squares. That's a 3x plus 2 times a 3x minus 2. And then last but not least for today, this is a quadratic form. I think the book we use may call it a method, but you start out just normal. 3p squared, that's my greatest common factor. It's going to leave that. All right, this is a recognition thing. I'm going to come off to the side and show you a way of thinking about it. Like, what if I took that and I let u equal p cubed? So I'd have a 5u plus 6, and then p to the 6 is a p cubed that gets squared. So I could say it's u squared And then that would factor down into u plus 2 and u plus 3, because what multiplies by 6 and adds by 5. But it didn't start out with u's. I made that up. So if I put what u is back in, then I've got it factored. So what we hope is that you don't have to actually go through that u substitution. But if you need to do it, you just look at this and realize, well, even though it's not a quadratic because it's to the 6th power, it's a quadratic type, because whatever sits here is that p cubed squared. So if that's the case, it's going to work like a trinomial. Like, what do I need? A p cubed and a p cubed. What multiplies be 6, adds be 5, 2 and 3. And that's it. We're done. Now, if you're sitting at home, Maddie, I'm talking to you, I know I just went through that really fast, and it's not going to make, like, we talked in class all period long about all these things. So just let me know if you need some help, and we'll get on.